Hey Jack.
Hey, how you doing? Thanks for joining.
Hey
Okay.
Jack.
Yeah.
Hi Jack.
Hey, Elf, how you doing?
Doing good. Oh, let's put the camera on too, so you see I'm still alive and well.
Yep, sounds good. So for the Keysight team, I appreciate you joining. There's been a lot of questions, as we get started with AstroSim, you've kind of built that UI front end, but
Hmm.
also kind of the traces, kind of the ecosystem, things like that. So, we're kicking off some places. We're going to talk to Tushar a bit more about generating traces for environments that don't fit, and specifically um, what he has working today. So, generating new environments, things like that, especially as we look at HPC, we look at Edge, we look at a number of different things. I'm working on data services. And so we're going to have a number of different ecosystems we bring up, different topologies, different deployments. And so I think as we go through the summer, collaborating would be key. If that's, and here's Yasha, he and I were discussing some pieces around some of the things he was doing. And Josh, I spoke to the HPC team this morning, mentioned some of your work, but they're going to reach out to Tushar and say, hey, how do we start generating these traces? What kinds of things do we do? Provide some more information. Let's get off the dime here. So,
That's good. That's good. I'm happy to talk to them too. By the way, I didn't fit it into my calendar yet to actually join for the HPC calls. I should probably at some point see whether I can squeeze it in now.
uh, so,
But
so for me, it was just an impromptu thing, but I'll do as soon as we get off this, I'll do an intro
okay,
because
cool.
as we talked, we have a small team kind of moving it all forward. So
Yeah. Do you know when their meeting is?
it's whenever I schedule it, same as I do with you.
No, I no, no. I mean the regular work stream meeting that the HPC one had.
Oh, so that I don't know. I'd have to
Mhm.
because I don't attend that. I
Ah, you
just
also don't go. Okay, okay. It's also just asynchronous for you. Okay, all good.
So as I sent an email to the Keysight team, I said it usually takes about 5 minutes for us to kind of gather, get to the point where we have enough people that we can actually get started, and then we kind of go from there. So
But I feel that's still every Zoom meeting, huh?
yeah,
Like I feel, at the university, I still get this a lot, where like all the talk, everything starts 5 minutes later now.
yeah. Well, at some point we are getting a bit better. I think that we went through a spell there where um, about 75% of the attendees were bots, recording so recording assistants, and so we are getting better. So
I had a meeting the other day where the host was late, but their AI assistant joined preemptively, and it was really funny because it was me and his AI assistant on the call for like 10 minutes. And I was just like, if I say something now, does this actually end up in his notes if he hasn't started the meeting yet? So I was like, what could I say that would be funny to see in his notes afterwards?
so um, so Yasha, I'll ping the HPC team, but then I'll ask them if there's regular meetings that they also go through in terms of that. When
Mm.
we do the OCP server meeting, it turns out to be it's just status of all the subgroups. So I just
Ah,
do
okay.
Wafeng and I do one of the statuses went on for 30 minutes. So we typically do the 30-second blow by, here's everything we're doing, provide a slide and go from there. Um, but Yasha, just for your information, you see Mike, who's on the call here.
Yeah, yeah.
Mike is from the HPE HPC team, and so
Ah, nice. Okay.
yes, so I share email with him and Semantica, who's also part of the HPE HPC. So I'll do an intro to both of them, and we'll follow up. But And then we've been talking about some workloads and things like that. But
Yeah.
the part that Semantica and I talked about is we won't get into vendor specifics. It's all going to be through OCP. It's going to be part of our modeling environment. It's going to be part of the ecosystem that we do. So we don't get involved in, proprietary kinds of things, but we want it to be an extensible model. And I think we're good with that. So. Okay.
Yeah, I just came off camera to say hi. Yeah, I'm happy to.
Mike.
Sorry, I'm eating as well in the background.
Okay. Yeah. So I'll do it, Mike. After the call, I'll do an intro
Great.
to you and Matt and Semantica with Yasha, and then because he was talking about taking some of his pieces that could possibly extend up in terms of algorithmically up to HPC, and so that way we can connect some dots. But we're all going to work collectively, and Semantica is going to reach out to Tushar about connecting some dots, so that way we don't all ping him individually about related requests. We're going to connect on that, and that's part of today getting together with the Keysight team. So I guess we've hit 5 after the hour. The session's recorded. As I said, today, as long as we want to go through as many questions, I know when we did the demo, when you gave me the intro, we could spend a whole hour on this, and so please feel free. I sent out, kind of what Weifeng and I posed for Global Summit, and our goal is to partner as we look at this as a framework which allows us to build out kind of a programmable modular ecosystem, whether we do HPC, we do AI, we look at algorithms, we look at some things like this, but it's really kind of a trace-driven way for us to look at different compute models, to look at different things like that. And so I guess without further ado, we'll jump into the Keysight if everybody's good with that. I think I apologize, it's late on Friday for some, but if you guys are okay getting started, doing an intro, kind of talking about the space where you are, and then we can kind of jump into the work you've done, the demo, things like that.
So Jim, this is the first topic on the agenda, right?
This is the first topic, and
Okay.
if you take the whole hour, we're good. So
Okay, thanks.
our goal is not to rush you.
Okay, so we can get started from Keysight. That's what you wanted, right?
Yes.
Oh, okay, so hi, this is Kingshuk from Keysight, and I'm part of Keysight Engineering. Has been focusing on layer 2-3 side of the networking protocol stacks and technologies. Then moved into software-defined networking, and finally, right now, for past few years, my focus in AI/ML network infrastructure, specifically the front end and back end networks and etc. So maybe I'll just pass it to my colleague Pradosh to introduce himself.
Hey, I'm Pradosh. I'm also from Keysight, and I am from Keysight Kolkata office. I started with Ixia earlier, then in layer 2-3, and then finally moved to L4-7, and maybe last couple of years I've been working with AI ML related stuffs, primarily on network infrastructure and related test solutions. So I'll talk more about what we are doing and all in the presentation. So with this brief intro, maybe Winston, you can.
Yeah, just quickly, right? Winston Liu. So I've been with this group at its inception, like maybe 3-4 years back before AI was cool. But I've been absent for a while, working with the guys back at Ixia and Keysight. I'm building a lot of these, I would say, like tooling, right, to help people evaluate different systems, emulators, real devices, real clusters, and simulations, right? So it's good that we're back to share what we've done with the community.
Harsh, maybe, yeah.
Yeah, hi, I'm Harsh, and I'm senior engineer at Keysight, and we are working on this, Keysight AIDC builder as well as infrastructure to define any network topology. So we'll present today both of these in this meeting, and let's see how that goes.
Sounds great. And from a team perspective, we have a smattering, from compute, network, storage, as well across a number of companies from ASIC to systems. And what we have decided for this year is to, we really focused last year on a polymorphic architecture, and so we wrote a white paper which allows us to look at kind of heterogeneous systems, composing, looking at capabilities, creating connection of resources to satisfy workloads, things like that. And so taking that specific aspect around that white paper and how do we turn it into something concrete for this year. And so one of the things that we had talked about is we could do compute, we could do networking, we could do a number of different aspects. And so we focused on topology. So how do we discover devices in topology? What kinds of things could we do to actually look and say, okay, based on some of the hypotheses we create around scale up, scale out networking. Yash has been working on some things around algorithms. We have some things we're going to do around data services. And so we're building out a more detailed white paper, which really can start to articulate some of the swim lanes. So for a scale-up network, where does it fit? What are the characteristics? What are the pieces for scale-out? What are the different topologies that we can create? What kind of services could we do? And then as we were discussing, as we were kicking things off, Mike is from the HPC team. And so we're talking with the HPC folks as well about HPC workloads, AI workloads, things that might be more edge or tailored to different kinds of compute devices. And so we've agreed on really starting to push AstroSim as a framework to allow us for scalable, but also to allow us to be far more composable and look at the different types of workloads to, as we theorize on the one side in PowerPoint and Google Docs, what's a way for us to actually validate this based on traces. And so AstroSim was the framework. And a couple of weeks ago, I had the good fortune to meet with the Keysight team after the intro from Tushar. And I asked that they would come back and show, okay, here's how they're actually extending, working on that AstroSim framework, and how do we work together? Because we would like to get to OCP Global Summit and do a collaboration across all the companies for a specific set of topics, which shows how this actually works together. And from this, you actually have an open repo in terms of your GitHub, as does Tushar. Can we extend that so that people can take this with their traces and try things out, look at different topologies, look at different interconnects, validate some of the work, and then also extend that for specific devices to test out some elements that they may be looking at. So that got us kind of our common point. And as I said, we're really kind of a cross section of everything from ASICs to systems, as well as different kinds of resources in the ecosystem. So our goal is to collaborate as much as possible, but also make it extensible so people can show their value add if they would like to do things privately in terms of this. We are not looking to, and I'm going to be crystal clear in terms of this. Our goal is to really look at the characteristics of the swim lanes for particular parts of the topologies. We are not here to bash one specific implementation over another, just show specifically, hey, these characteristics work well for this space. And if somebody has an implementation or a device that fits within that, then then they can articulate that. But we're not here to bash one versus another. Okay. So the Keysight team, you can kick off. I'm going to go on mute, otherwise I get to be real chatty.
Sure. So maybe we can start. Harsh, maybe you can share the slide.
Yeah, give me a
So
second.
yeah, so the way we thought of, like, we'll give you a high level idea about the ecosystem that we have around the AI solutions in Keysight, and we will show a quick demo. After that, we'll show a quick demo of what application we have and how we are kind of using AstroSim. And then we will dig deeper into the infra proto. That is what we are using for defining our network topologies and all internally. So we'll take from there. Harsh, maybe if you can go to the next slide.
Right.
Okay, so this is kind of the high level topology that we are using, high level architecture that we are using to represent our solution around AI ML testing products, as you can see. So we have the top layer, we have different applications, which is kind of infrastructure benchmarks or to test a particular uh, network, or even some applications which are or which can be used for replaying traffic or some traces captured from other training. So in the top left corner, if you see that that application is kind of allows the end user to run different collectives, different algorithms with different data sizes, and see how their duty or their solution or product behaves against those collectives, how quickly they can do the training, and those kind of measurements we provide. Then we have this network design part, and then the workload emulation is kind of where we allow the user to replay different traces that are captured in a real training. Here, basically, we integrated with the Chakra also. So as you know, the Chakra traces can be captured from a real training, and those uh, captured ETs or those ETs can be basically replayed through our product. We have similarly another part that is for ASIC validation. So I'll not go into the details of all applications, but as you see the third layer, here we have all the platforms where we have at the left side, we have the Cadence and Synopsys. We partnered with them basically to do the pre-silicon chip design validations, where the engineers can use our traffic generators or our benchmarking tools or applications and pass the traffic through these and these products, and they can tune the traffic, and that is how this particular platform works. Then we have the hardware emulation part, which is kind of, as you know, Keysight has a range of hardwares, starting from few 100 Mbps to 400 Gbps, 800 Gbps, and also even 1.8 Tbps, which are kind of can generate high performance traffic, high throughput, high connection rates, and all. So basically the end user can run all the traffic, all the AI related training traffic through those hardwares, and we can measure how the DART or the system under test is performing with very accurate nanosecond or sub-nanosecond in some cases accuracy. We have some software platforms also where we actually support our applications on top of some off-the-shelf boxes with some network NICs, like it could be a Rocky NIC or any other general purpose NIC. Then we have some other emulation platforms. But at the end, if you see the highlighted box, that is the simulation part here, where basically we have integrated our product, our platform with some commercial solution. We partnered with a third-party company, as well as we have integrated our solution with AstraSync. We will come to that. We'll show a demo with that. So basically, if you see from top to bottom, like the user gets the flexibility to run different applications using a common framework, and they get the flexibility to run our solution across all these platforms, starting from simulation to hardware and all.
Okay. So I
Yeah,
think just to sorry to interrupt, right? So I think just to be brief, right? Like I think going back to Jack's comment earlier, right? So this is just showing you sort of what we built. So it's not to really sell, right? But I think what we really want to highlight is that we are aligned to the ML Commons, the Chakra workload definitions, and what we've open source, right? Right now, it's at the Keysight property is this concept of this infra.proto, which is a description language or schema to describe any type of infrastructure and and the schematics, right? How different components can connect together and things like that. And we believe that these two pieces are actually the ones that allows people, right, to actually, if we actually standardize a lot of these things, people could actually build around them, right, to build their own tooling, their own workflow, or whatever it is, right? And then we've used exactly these two sort of common parts to actually, build the solution.
Yeah. So when Chakra gives us the ability to use or define the collectives or the traces, the infra gives us the way to define the underlying network topology. So that's the benefit we are getting from this
So
common
again, right,
definition.
like one thing there is I know we speak a lot about network topologies from our side because traditionally we're Ixia, we're about networks, but I want to reiterate, right? Infra.proto is not just about the Ethernet network, or it could be about scale up, it could be about PCIe, it could be about anything. That's how flexible that schema is.
Yeah.
Okay, so just can I ask a couple questions around? One is specifically about the ML Commons work. So I take it that you're directly participating in the ML Commons Chakra working group, and things that you're doing are adhering to what the schema that they're proposing.
Yeah, I mean we're there from day one with
Okay.
Tushar and Srinivas. So
Okay. Yeah, I haven't participated in a while, but
yeah.
I was aware of.
So we are in both places.
Okay.
But we think infra.proto is the one that's a missing piece, because you really need the common definition of the workload and some logical description of the infrastructure schema, right? Which could be any components, how they're interconnected. And then the two of them together is going to allow people to, try different things, right? And build different tooling or whatever.
Which kind of goes into my next question. I don't want to steal any thunder, but are you going to talk about, say, the memory and the storage components? Because these are things that are kind of lacking even within AstroSim. So are you going to talk a little bit about that?
No,
Oh, okay.
Unfortunately. But what I'm saying is I think the goal here is I think that's where I think the beauty of these schemas being public, right? That we could enhance it together to address other domains, right? But because at the end, it's about data movement, right? So.
Okay, thanks.
So Brian, one of the things that I talked to the Keysight team when we originally met, if we look at like extensible device types, and then we start to look under as Winston was talking about, kind of that topology and the description in infra.proto for a given trace, can we describe different kinds of devices? So that's what we've been talking to Tushar about, for memory, Namsung with memory, and then Tushar about extending storage, and then Weifeng and I talked with Jay at the beginning of the week about storage as well. So it's an area that we're going to go through and start to look at. But I think those are valid points. And as long as we look at kind of this compute communication model, and as Winston talked about, with being able to describe it in infra.proto and certain devices, then I think we're at least headed in the right direction.
Yeah, and even within ML Commons itself, and Winston, and Pradesh, you probably ran into this. It's like, well, gee, can we use Chakra to be able to capture IO so we can help it and use that trace to generate ML storage, ML perf storage benchmark, right? There's those kind of discussions that are going on too. And it might not be the right thing to do, but kind of to your point, it's like, what is the overall thing that I can test and which component do I want to test, and allowing me the flexibility to target the things I want to target within this system.
Right. Because I think ultimately you want to be able to have those common input, right? And description of the environment, so that if you actually start with simulation, you could try it on some emulator, whoever provides that, or try it on the real system and compare them apples to apples, right? Otherwise, all the inputs are actually different.
Yeah, no, exactly. No, I agree. So, okay, good. Thanks.
Okay, we'll go in some details in the infra-proto. We'll show like how we can represent different components of a particular host, or as Winston is saying, like scale in and scale in and scale out and scale up. All those combinations can be represented. So let's start with the demo. We'll just go over, we'll just show you how we run, how it is integrated with our solution, how it looks like, and then we'll dig deeper in the infra. So maybe Harsh, you can take the share and
Yeah. Just a
start
quick
with the
question.
demo.
Is my
Yeah.
share visible? I think I
Yeah.
lost it and
No, right now it's visible.
it's visible, right? I'm losing the share. It's I don't know. There's some, but it's visible, right now.
It's right now it's visible, but it's sometimes going. But
Okay,
right
got
now
it.
it is fine.
Got it. Yeah, yeah. I'm just losing that share again and again. Okay. Okay. Just let me know if the share goes away. I'll just try to reattach that. Okay. So moving on. I'll just show a quick demo of our solution with Astrasim. And so our solution is Keysight AI DC test platform, and this is our main, homepage. And we have a bunch of application, presets. So for now, we'll be showing the collective benchmark, where we'll be running a single collective over one fabric. This also allows users to store the reports. So for any, collective run, the results get stored so that you can, compare and check them later on. So moving on, okay, I'll just quickly go over the demo topology. So yeah, this is the demo topology that we'll be running. And you can see that there are 16 hosts in this fabric, and there are 2 rack switches, and there's 1 pod switch. Now, the idea is that we'll be running an all-to-all, with a data size of 32 MB, just to make it quick. And the link bandwidth will be of 100 Gbps. So moving on to the collective benchmark application. So this application is divided into 3 parts. The first one is the benchmark config. So practically in this space, you configure the collective and the data sizes, the protocols, and so on. The second section allows you to configure the network topology. And the third one allows you to select the platform. So from the previous slide, you have seen that we can run it on Keysight hardware or software. And there's another simulation factor that we have added, with Astrasim. So I'll just quickly configure the collective. So right now the collective is set to all, which is our desired collective to run. But if we have support for a bunch of other collectives as well, as you can see. So I'll just select all and we can select a sub algorithm. So right now we have all parallel implemented in our KCCB system. So I'll just use this. The data size we can add as a multiplier or as a list. So for the simplicity and to make this demo quick, I'll just use a data size of 32 MB, which I have already pre-configured. And then I'll just keep these options as it is, for the sake of the demo. And, we have to cover infra as well. Moving on to the topology, we have, defined a flow fabric builder. And in this case, a second. Yeah. So in this case, you can just select the type of fabric. You can either use a black box fabric. If you're using Keysight hardware, you just want your fabric to be black box, and you just want to run some collective over Keysight hardware, right? Otherwise, you can define a whole flow topology for simulation, and you can define the host as well as the tier, the levels of the infra. So for the sake of this demo, we will be using a 16 host topology with 100 Gbps NIC speed, and we'll be adding 2 tier configs. So as you can see, there's a tier 1 with a switch radix of 16. So the down ports are 8 and up ports are 8. And then we'll add another tier, with a switch radix of 16, so that both the back switches, which has an uplink of 8, will be fully connected to the tier 2 config. And I have kept the port speed at 100 for both the tiers. And I'll just move on and set the final host count to 16. Now, since we have already configured our collective, the network infra as well as the physical setup, I'll just hit on run file.
Question?
So, yeah, sure.
So collectives, they are just maintained at the endpoints. You're not expecting any in-network compute in this topology, right?
That's right. There is no in-network compute. It's
Okay.
not time.
Got it. Thanks.
Right. So as you can see, this is based on an OpenAPI, definition. So we defined an OpenAPI for Astrasim, and we implement the server and client, and that client is working with our solution, to run some test cases on AstraZeneca. I'll cover the design aspect after I showcase the results. So in this case, we show a few results to the end users. The first one is the summary stats. It's the total overall summary of how the collective has been performing. And we have given some metrics like the completion time, the algo and bus bandwidth, the idle percent, as well as, some percentile calculations for the flow completions. The second stat, which is interesting, is the flow stats. So here you can see we are running, we ran a collective, all to all over 16 rank, system, right? And then it was split on 2 tiers. So we can see like, how 8, flows are completing, at single point, and the other 8, which is in rack 2, are completing at the same instance. But when there is a cross communication happening, then it takes, a longer time to complete that flow. So we have some, interesting filters as well. Like, we can just add like source rank, we can give like value 0, and we can see how source rank 0, flows are behaving and how the time looks. So with these filters and with other options, you can, drill down on stats, and you can see certain, flows that are interest for you. We also have a CDF plot where we show, the cumulative distribution frequency for all the flows. And you can see like, how the, 8 flows are taking less time, and how, the cross flows, like a hop flow, is taking more time, right? And yeah, we have flow and port metrics, but as for SIM, we just kept it very simple for the first integration, and we kept it minimal. And we just went ahead and implemented the major stats that are required. So this is a quick demo on AstraSim with our Kai DC test platform, and I'll quickly move on to the underlying tech, how we achieved this. So the first idea is our KCCB, or the collective communication benchmark application that I showed you, is a plugin based architecture. So we can add any plugin to that system, and we just get some common configs, and the plugin can just run it, execute that. So using that plugin based architecture, we defined an AstraSim plugin, just to convert to certain characteristics of AstraSim. Now, those of you who don't know, AstraSim has like support of multiple backends, and we can just configure each backend and get the stats. So for this demo purpose, we used the NS3 backend for AstraSim, and we created this open API schema, that serves as the client server architecture, as well as gives us some schema that both the client and server has to respect. And the plugin sends data to the client, and client communicates to the AstraSim server, which in turn communicates to the AstraSim binary and runs the simulation. Now, once everything is over, we just collect all the files through this client, and we translate the results and show it in the UI. So this is a very quick and high level approach on solving this integration issue with AstraSim. Now, moving on to the infra design, which is the second portion of our collective benchmark application. So in this case, I'll just cover how we define a network topology. So moving on, the way we thought of network topology is like a graph. So you have like all the devices in the network, and you can connect devices in the network, and that forms your edge. So if you consider the device as nodes and the connections as edges, you just get a complete graph, right? And this gives us a very generalized way of defining topology, like an assembly language. And with this, we are not enforcing any kind of constraints on like actual topologies. Like a flow fabric may have some different variations, right? So there's an academic flow fabric which is like an ideal flow factory, but it may happen so that some may use a different variation of flow fabric, and we want to support all these variations without giving a perfect or limiting the infra design. So we approach this problem as a graph, and we kind of model the devices as nodes and connections as edges, as I said. And the way we do it is we allow the ability to define or model a device as well as its components. So on the right, as you can see, this is a diagram and it summarizes the whole infra proto, our definition of infrastructure. So the way we saw it is, you define an inventory. An inventory can have like devices and links, right? So devices forms your nodes and links forms your edges. And this device acts as a, as a class, as a blueprint. So practically you can define, multiple hosts like a TGX, Xionix, or a generic host, even a generic switch. And you can just instantiate those devices. So you just make, objects for that device. And using the device instances and links, we form the connections. So I'll cover these aspects one by one. We'll build infra together as I move ahead in this presentation. But this is like a high-level overview of how we define the infrastructure. Now, as you can see, the device has components and has device links and has device connections. So practically, what we saw that each device can have like let's consider a simple host, and a host can have a NIC or an NPU, right? And those two are connected using a PCI link, right? So we thought of modeling the components, like you can model a NIC component, an NPU component. You can also give the count, how many NICs are there in the system. You define the link like an MII or a PCI link, and then you also define the connections. So with this device, bucket, you can define the whole device. You can define the components inside that. You can define the internal wiring of the device. And with the instances and the outer links, you can define the overall, external connections of the topology. So I'll just cover one by one, and I'll also talk about annotations, at the end. It may not mean anything, but as we move ahead and build infra together, this will, make, it will be meaningful at the end. So here we'll be building the infra, right? And right now, let's take an example of a simple, rack switch, and we want to connect like 4 nodes, to that rack switch. So how do we model this infra? Now, let's model the switch in the beginning. Now, we just visualized like a generic switch will have like, some ports and an ASIC, right? So in this case, I'll just take like a 4-port switch, and an ASIC, which is connected via MII. So there are 2 components, again, ASIC and port, 4 ports in this switch, and then 1 ASIC, and the ports are connected to ASIC by MII. And the way we think is, the way we thought is like each component, once we define the component, we can also define a count of the component, because the component properties are going to stay the same. Now, let's say if there's a different component, which acts like a port, so we can add another property, another component to the device, and it will act as a different component altogether. So just to keep things simple, this is like a 4-port system with an ASIC, and you can see the connections. So it's very simple. Now, I'll just try to relate whatever, how we design the infra to this diagram for the switch aspect. So as you can see, this is, the device definition, which we thought of modeling, a simple switch. So you can see, we said that, it has like 2 components. One is the ASIC and one is the port, right? So we can define like 2 components, like a port down and an ASIC component. I can give the name as port. I can define the count as 4. So I just want like 4 port components in that switch. And the type is of NIC, which is of Ethernet. Then I can define an ASIC component, with, the type as CPU, and I can just give the memory as memory RAM. Now, these types are defined by the infra schema. They are already present on our GitHub. So if anybody wants to take a look, you can just quickly look at it. But for simplicity, I'll just, skim through, just on the building blocks. I'll just focus on how we build using infra. Now, as you saw from my previous diagram, I just took out the section for the inventory, and I'm just highlighting the device. I just gave it like a bright and punchy colors, indicating that this is, under building. And the component has 3 different options like name, count, and type, which I already discussed. And this is how we define the device components. Now, moving on, we want to link, or connect the components within the device. So we define a link inside the device. So this is a tier 0 device. Sorry, I just forgot about it. So we can give the device name, and this is like a key value pair. So I can just give it like the inventory name for the device as well as the internal name for the device, like what we are going to call it. And in this device, this is the component section and this is the link section. So I define an MII link, and then I define the connections which represent connection between two components in that device. So the way we define connection is we just give the component, we give the index of the component, we give the link, and then the destination component as well as its index. So you can select port 0 is connected to ASCII A60 using MII. Similarly, port 1 is connected to A60 using MII. Port 2, port 3 follow the same. So in this way, we can scale it up and add, NPUs, NV links, and we interconnect switches, right? As well as a lot more, components which the device has. Now, this is how we modeled the switch. Now, let's move on to modeling a simple host. So the way we visualize a simple host is it will have a NIC, which is connected to an NPU through a PCI link. And, we can just move ahead and model the same. So again, I define a generic host device, with two components, a NIC and an NPU component. We give the count as 1, 1. We set the type as NIC and an NPU. And then we define a link called PCI. And then again, we connect, these components through, PCI link. So as you can see, it's NPU 0 with PCI, it's connecting to NIC 0. So we define both the devices in the infra, and let's move ahead and let's try to connect both devices. Now, the way we connect devices, we just connect, a host NIC, to a generic switch port, right? So as you can see, there are 4 hosts and there is 1 generic switch. So we already have defined a generic host, right? And the idea is that we can just, create objects of the same. So there we have, the concept of a device instance, which I'll cover in the later slides. Now, again, this generic host is connected to the switch using some link, and we'll define a link as well as we move ahead building this infra. Now, moving on, as I said, we'll just cover, how we connect the links. So you, from my first diagram, which I showcased about the infra, you see that there is a link section, right? And this link section represents all the external links with which the device is connected. So as you can see, we defined like 2 devices, the generic host and tier 0. It's a big, JSON, so I have to like compress it and show it here. But this is a part of the inventory. And the inventory has the device, and we defined this device in the previous slides. And then we have the links. And this is the external link. So we are defining a 100 Gbps link with the bandwidth as 100 Gbps. Again, these are defined by the schema. So once you browse Keysight infrastructure, you will get all these placeholders as well. Now, with this link, we'll be connecting 2 devices. But before we connect devices, we need to instantiate those devices, right? So we just created a blueprint of the devices, and we would want to create like count of the devices or objects of the device. So moving on, I added another block from my first diagram, which is the device instance. So as you can see, there is an arrow from devices to device instance, and we define 2 devices, and here we instantiate those devices. So tier 0, I just instantiated the tier 0, the caps tier 0, which is under devices as small case tier 0, and I give the count as 1. And I instantiated a generic host with a count of 4 as generic. So this is how my device instances work, and you can see like how the device instances is mapped to the devices. So let's say if anybody wants to check device of a particular instance, they can just take this device value. They can check in this quick map, and they'll just get the exact device that they're looking in the infra. Now, since we have the devices, the links defined and the device instances, we'll start building connections, right? So the way we build connections, so I'll just go back quickly and I show how we build the connection. So there is a source device and there is a source device index, right? Component, sorry. And there's a component index as well. And there is a destination device, with a destination component and its index. So we quickly modeled that up and we came up with a quick string lookup where, you see the first, 4 separators like generic.0.nic.0. This is a source device. And then the last 4 separators, the tier 00, port 0 is the destination device. And these are connected via this 100 Gbps link, which we defined. Now, the idea is, we are taking the device instances, with the instance name, the instance index, with the component name and its index, and then we are connecting to the destination counterpart using this link. So this is how we, connect all the nodes in the topology and, create, this up. And in this way, we can just keep, like defining, devices as well as device instances, and we can just scale this up and out to create like, a full data center interconnect topology or any kind of, different new variations of topologies that come. Yeah.
And the idea is that like as you scale up, right, your infrastructure, like in terms of components or how I would say like granular you want to describe it. If you want to do super granular, typically then you would write a piece of Python code, right? Because a lot of these systems are well structured, right? Then the code itself would then spit out, basically the schema in this form, and then you could render it, like instead of the binary form in protobuf, you'll see it actually in JSON or YAML, whatever. Right? And this becomes like the common language, right? That any tools downstream elsewhere could then, if they choose to leverage these additional, sort of hints or large, definition of the system that you intended, right? They could actually do a lot of different things in simulations, emulations, or whatever.
Right. So maybe I can just take questions at the end. I'll just quickly cover a few more aspects. So moving on, the annotations part, right? So as you can see, we defined the whole infra and, we just, created a bunch of devices and, instantiated those devices and connected them using links, right? Now it may happen that we may want to add more information, right? Like let's say we want to add like routing tables to a certain device. So we came up with another proto definition, which is called annotations. Now the purpose of annotations is, to attach or, bind some data, with certain parts of infrastructure. Now the way it works is, we have 2 definitions or, 2 parts for annotation. The first part is the target and the second part is the data. So by target, we can just, link up, any part of infrastructure that has been defined, like the device instances or the whole infrastructure, or even a single device as well, or even device components as well. And we can add like a custom schema, or a data. It can be a key value pair or any, vendor specific data that anybody wants to attach. Now, the objective was to, let, infra act freely, like let the graphing be independent of all the bindings, as a separate identity. And the annotations can be like vendor specific models, right? Like something that may be internal to some organization or some, groups, right? But, if we, the another idea was like, if you just want to share your infrastructure with someone, you could just share that infra proto rather than this binding thing, which may have been internal or which may contain internal schemas, right? So this was the main purpose, like to add, like, just to give flexibility to add more context and content, to certain parts of infra. I'll show a very quick example of this. So let's say, we define this generic switch and, generic host, right? And, so it may mean something to you. And, this generic switch.0, like if you saw from my previous slides, we were referring this to as a tier 0 device, right? As a tier 0 device instance. Now it may happen so that, for some people, the tier 0 may mean the leaf nodes, or tier 0 may mean something else in the system. So we define, in this example, we'll be defining the type of device, this tier 0 and this generic host is. So the idea is, we define a custom schema. The custom schema has 2 key value pairs. So the first key is the device instance and the second is the device type. So in the first key, you can just add like which device instance are you referring to? And the second key is the device type, like which.
Excuse me, Harsh, like just a quick time check, okay? We're almost at 10:50, okay? Like
right, yeah. Thank you. I'll just be quick with this. Okay. So we just add like the device type to any device instance, and these schemas can be internal to organization. So I'll just quickly show how this looks. So as I said, we can define the targets like which infrastructure path are we referring to. So here I'm referring to the whole infrastructure, and inside this I have a schema which where I give a name as device types, right? And then we give the value. So I said that there are 2 key value pairs. The first is the device instance and the next is the device type. So I just set the device instance generic to a type of host and the device instance tier 0 to a type of switch, right? So these schemas can be defined, can be shared by others, who would want to check annotations, or can be, used internally. But, these keep, infra very independent from, with the intent, right? Like we are defining a graph and the bindings as a different set of objects. Moving on, infrastructure conversion, sorry. So as I showed in AstraSim, how we are, defining the collective, the network infra, and I just went on speaking about the infrastructure. Now, where this comes into picture, so since we are using AstraSim NS3 backend, we would want to convert our infra to NS3 physical topology. So NS3 takes like, a topology in this format. It's available on AstraSim, wiki pages. And we can just quickly convert, our infra to these cases. In fact, not only these, we checked with others, and we were able to convert to any specific set of infrastructure, during our work with infra protocol. So yeah, this is the overall gist about infra, and I hope it was clear. So any questions?
Mainly, it is useful for the checking the management part of the fabric, or we can do some kind of testing for the actual data plane as well.
Okay, so
I can take using the infra.proto. What we can do is that we can describe an infrastructure, network infrastructure. Well, it can be anything else that we want to simulate or emulate. Say, for example, if we take AstraSim as an example, I want to simulate an leaf and spine network or in AstraSim. So how do I describe it? Harsh is showing that how it is described today in AstraSim on the right-hand side of the picture. What we are giving is a more of a generic way of describing a network infrastructure, any infrastructure that we want to emulate or simulate in a more I'd say structured manner, in a more I'd say machine parseable format. And this is platform agnostic. So once we describe our network infrastructure, then respective platform can convert into that platform specific semantics. But what remains generic is the description in a generic manner. Now, coming to specific to your question that, okay, with this, I can tell AstraSim to okay, this is the network I want to simulate. Now, when it comes to the testing capability, it is the testing capability of AstraSim, whether it will be able to do the calculations or the simulations to fill up a pipe or do some congestions, etc. This depends on what is the capability of the underneath tool. So if the underneath tool has the testing capability of various features, yes, you can fire the test. But to run the test on what topology, what infrastructure, what do you want to emulate before we start the test, that's where infra.proto comes to describe an network infrastructure in a generic and platform agnostic.
Yeah. So think of it as almost like, sorry, just one addition, right? So think of it as almost like with the same definition on the right? For example, if you are using open source AstroSim, right, you have a way to actually have a common definition that gets, sort of translated down, get some results from AstroSim. But if you happen to have other tools of your choosing, right, provided that tool actually understands this common format, right? Like some people need to write some code, right? It's very similar analogous to, the switch abstraction interface from OCP, where you define the common definition and different vendors from the switch vendors like NVIDIA or Broadcom or anybody else, right, have their own internal SDK and format, and somebody is able to fit it under that interface, right? And you now have a sort of common language, right? So that's the way that I think we should look at infra.proto. Infra.proto by itself does not do tests. It's actually providing a vital piece of information, right? It's like I said, it's one of the input to your whatever you want to test or simulate or emulate or run in real life, right? Is one part of the information that describe the environment of your target infrastructure, right? And then plus you have the common description of the workload, right? If the underlying tool, whether it's simulator, emulators, whatever, could understand those languages, then that tool can then do the job that you want, right?
And that underlying tool could be real hardware as well?
Yes, that's the intent,
Yes.
right?
Yes.
Yeah.
Okay.
It could be
So
simulator.
that's why you're able to then, run some simulation, get some results. When you have the hardware prototype, you should be able to plug that hardware prototype in there and say, hey, this hardware prototype is representing, for example, this, the first rack, for example, right? But my eventual infrastructure is 4 racks. Now I feed all this information down to the test system. The test system know that the first rack is a real thing, right? But the emulation needs to behave as if it's the other 3 racks plus the fabric, for example.
Yeah. So we can start with the management interfaces earlier, and then as the actual hardware become available, you can get into the data plane and the real testing as well.
I wouldn't say it's about management, right? It's more about just like, I mean, I guess you could use it for management as well in some ways.
Because it's doing the topology detection and
Yeah.
everything, so seems like it's a good tool to do that. Yeah, thanks.
Yeah, I mean, you could use it for that too, right? If providers like we have a common definition of what the infrastructure looks like. So
Okay, we have a hand raised. So go ahead, Shaman.
This is great contribution. Thank you very much for sharing with us. And based on what I'm hearing, this could be used before the hardware is set up, as you said, emulation and simulation. But the terminology, semantics, and language you're creating here is very much applicable in discovery, enumeration, and topology diagram based on real hardware as well. As part of the composable memory system sub-project within OCP and memory fabric forum that we have, memory fabric orchestration forum that we have, there has been discussions about discovering elements and how they're connected for the sake of management, for the sake of composing memory or storage or GPUs to CPUs, and eventually debug and analysis. So in other words, this is a wonderful tool. Now the question to you, I did understand that you're open sourcing some of these, perhaps not all, but at least the semantics. In what way could others benefit from your work to plug into their source code?
I think right now it's more about open sourcing the semantics, right? Like the schema itself, very similar to how switch abstraction interface, very similar to chakra itself is a definition. And I think what Harsh hasn't shown today, right? Because I think we're running short on time, is that there's also some visualization tools that can help people if you have one of these like really large definitions. There's a way to visualize it and things like that. And I think all those things are gonna, we should talk about how that would be, whether those are helpful for the community or not, and things like that, right?
Yeah, they're of course helpful. It's just a matter of getting access to starting to take a look and see how we can use them.
Yeah, I think we're open to discuss the next steps, right? Like what are the maybe like some of the things, right, that enable people to actually, whether it's examples or additional visualizer or whatever, to work with the schema.
Right.
So,
and on the annotation aspect, are the annotations free form, or are they also structured fields that later you can query on them?
Yeah. So I think right now I think the way we structure it is very flexible, very similar to Chakra. But I think the key is like, this is why I think we want to bring it to the community, right? It's so flexible right now. It's free form in some ways where you need to define, it's kind of like a TLV, right? You kind of define your type and value and things like that, and with the name. But I think what's worth thinking about is like over time, if this is really a community effort, it's like once you see certain attribute keep showing up all the time, it would be nice to actually promote it to a more first-class citizen, like you said, right? Something that's more permanent versus freeform.
Thank you.
But now you have like options essentially, right? You could go really flexible, or over time evolve it, promote things and things like that.
Very good. So, in what way could we start playing with the tools that you have?
I think right now on our GitHub is only the schema, right? And I think that's the part maybe we need to discuss, right?
Yeah,
I
it
think what we've
needs more.
shown very early is more like we're showing the examples how we use it as a commercial product, right? But we want to make this common definition available first, and then let's see what other utility that's beneficial.
So,
right? I think we're open. So,
Shavik, I'll ping you offline with Brian and Weifeng, because we reached out to Namsung around data services and how do we start to exactly what you were describing. How do we start to look at that from some modeling, topology, device modeling aspects? And so I'll ping you so we can start to look at this and how does it fit in kind of the AstraSim work, and we can reach back to Winston and team about what are the ways that we may want to leverage the schema extend or formalize some of the schema.
And one other thing is like we are also discussing with Tushar, right? Like for example, some of these extensions that we did to AstraSim to actually like make it actually be able to sort of access its functionality remotely, like all these open API and the server side sort of implementation of that to drive AstraSim. We're talking with them about, like providing that for everybody as well, right? So that, yeah.
Well, I'm gonna be real clear. Tushar wants to move his AstraSim much more to open. So for us to continually to pivot back to Tushar, who travels and has limited availability, I think to Shyamik's point, how do we start to work together and keep him, keep in the loop? He's still kind of the shepherd today, but if he definitely wants to open source, we're going to probably have to take a slightly different approach to drive some of this to move it forward.
Yeah, I'm saying even that, like I guess what we're saying is like we're open sourcing that little nugget, right? That we sort of hook in front of AstraSim to be able to drive it, right? We're open to open that integration for that server piece that we use in order to talk to AstraSim. But I think the core piece of AstraSim is like you said, right? That's up to Tushar. But our intent is to donate that other piece in front of it also to him or wherever AstraSim lands.
Even before getting access to the source code, in other words, before you open source it, to better understand the schema and the terminology and capabilities in the language that you're creating, it'll be good for people to play with your tool, not the source code, but just to run it, to get ideas of what's possible and provide feedback. For example, the thought that came to me about annotation. I can annotate something in there that's useful for a particular system. Later, I might be able to like to do a query on top of that for a very large scaled up system. So I don't have a good feel for how useful it is before we start playing with these things.
Right. So I maybe like what we could do is like if we figure out a way for us to collect some of those use cases, and maybe we could actually go back and then try to use it ourselves and to describe those use cases using infra.proto and share it as examples, right? To actually learn together, right? And I think that's also part of it is like, we vet it against at least the use cases we know of. But, I think having more use cases will actually pick out like weak spots or anything, right? With this definition, anything we can enhance, and then, let's work on it together.
I think part of it too, though, CMOC, is that, I mean, there is a little bit of self-learning that can happen too, where people can actually go into the ML Commons group, look at what's going on with Chakra just to get an idea of what other people are doing within Chakra before even, trying to get up to speed before, engaging, with the Keysight people. So I think it's going to be a little bit challenging because the original, to me at least, is some of the Chakra stuff was originally network focused. That was kind of the intent of the paper. And so I don't know if you've seen that paper, but at least it'll give you some background on Chakra and its original intent. And with the work that was done at Meta, and then also the current capabilities of AstraSim. I can forward you those papers just so you can get a sense of how that these two key blocks are there, and then the work that Keysight is doing with respect to the extraction of the scheme and the kind of consolidation, actually making it work on just real things, is kind of, then you can kind of understand at least what the source of the work was that now they've kind of fleshed out, I think, much better, much more clearly. So.
Okay, we've kind of run over a bit. Yeah, Brian, if you could kind of post the paper, I saw Weifeng's note in at least the link in terms of email, that'd be fantastic. And I want to thank the Keysight team. This was really informative. I think, Shamik, to your point, we'll connect on some use cases, examples, and where we can collaborate as like OCP Server sub-projects in terms of some pieces, but definitely connect back with Winston and how far we can actually do some work together. Thank you very much.
So Jack, do you want me to put that to the like the AI hardware software co-design, or just
If you would, or if you send it to me, I'll post it. I'll post it as a new message. Either way.
Okay. Thanks.
Thank you, guys.
Okay. Thank you. It was great. Thank you so much.
Bye.
Thank you. Yeah.